This is the big lecture video of today. The way a lot of the bone and then later muscle units would go is we would have a lot of lecture stuff, and then we would kind of move into the lab where we have models, and I could show people things and act things out and wave my arms around. When we're doing things online, we have to approximate it as best we can using software and videos we can find. So we would always kind of start this day with this lecture. So let's get into it, and let's enjoy learning some anatomy. Okay, so joints are the articulations I've talked about where we'd say this bone articulates with this other bone. And in most cases they're bone to bone, but we will see some bone cartilage, and then also the teeth go in their sockets and they have a special kind of joint. We will pretty much skip bone to cartilage articulations in this class. So joints will vary a lot in these two parameters. So you could imagine the shoulder is very mobile, but occasionally someone will dislocate a shoulder, versus the joint between the parietal bone and the occipital bone in your head. No one ever dislocates that, but it is also not mobile at all. So there's kind of a trade-off that joints have, and a lot of joints do have protective structures around them that we will see. And in some cases, well, a lot of times what they're doing is protecting the bones while they're also holding them together and letting them move. So this is kind of the trade-off between mobility and stability. These are the crazy examples. The shoulder or the glenohumeral joint, that's the most mobile joint in your body. It can do the most degrees of motion. The hip joint is kind of a close second. And then on the other end of the scale would be sutures. The one I talked about would be the lambdoid suture at the posterior aspect of the skull. Okay, so there are different ways people will classify joints. When you read about a joint in a textbook, you'll see different words used to introduce it. And those words would be their classification, whatever group they fall into. And one of them would be function, or sort of ability to move. And that would be these words here that you will see when you learn about joints in other classes. For us, we're more interested in the structures. And so we are going to classify joints just based on what connects the bones and how they are connected. So you'll see we have a bunch of different types of joints. We group based on what holds the bones together. So the structural definition is based on material, and then there's like the material that holds the bones together, and then there's another group, whether they have a joint cavity. And if they have a joint cavity, it's much more complicated, but those all have some things in common. So we'll start with the fibrous joints, and these are held together by dense regular CT proper, etc. And then we have cartilaginous joints held together by cartilage, and then the rest of them are synovial. These are the ones that have the joint capsule, or the synovial capsule, full of synovial fluid. That's the fluid-filled cavity. And I'll just give this away right now. All the joints that you gesture with and move, all the joints that you pretty much, most of the joints that are going to do flexion and extension, your shoulder, elbow, wrist, all the joints in your hand and fingers and your toes, they're all synovial joints. So these are the last ones we're going to get to, and the majority of joints that you will care about in your career are going to be synovial joints. But we're going to start, we'll get the simple ones out of the way. And this is your big table of joints. You have to, well, you basically have to be able to write out this table and explain it. So if I ask you for 3 examples of fibrous joints, you would write these 3 and tell me what these mean, or the description of them. And that's usually an essay question on the exam. It's like in the past I've asked for name 8 different types of joints. So they have these 3 classes and then all these types within those classes. Some of the other professors would just say name all the types of joints. I am not into that kind of thing. Okay, so we'll start with the fibrous joints. These are held together, by dense fibrous tissue. The idea is they hold the bones tightly together, but it's slightly more flexible or more able to grow than just bone itself would be. So sometimes it's useful in an organism that is growing quickly to start with several bones and then fuse them together, and that's why we have like skull bones and sutures. Remember, the skull bones have to form very early in fetal development to protect the brain, and so the fastest thing that we can do is have several of them start developing at the same time and then grow to meet each other. So that's my wild speculation about why sutures exist. Then we have the syndesmoses, and these are where the bones are connected just by ligaments. And that would be, we would see these in the interosseous membranes. So the ulna and radius are held together tightly by this interosseous membrane. And the tibia and fibula are held together the same way. Also, there's the one other joint, the distal tibiofibular joint, which you can't really see. There. And these do allow some movement. I mean, not so much this one, but obviously you can pronate and supinate your forearm. So that means this interosseous membrane has to allow the radius to roll so that the distal end of the radius can roll anterior to the ulna. Your leg here with the tibia and the fibula don't really do anything like that. They're nowhere near as mobile as the forearm. Their job really is to stabilize the ankle and hold your weight. So there's that. Okay, so the third type is for teeth and a socket, gomphoses. That would be plural. Gomphosis would be singular. And they're held together by the periodontal ligament, which holds the tooth in place. That's all I really want to say about that. I'm not covering teeth in any detail this summer. That was the fibrous joints. Okay, so it's as simple as that each one of them is held together by something slightly different, but what they all have in common is fibrous connective tissue doing that work. Next, we're going to move to the cartilaginous joints, and these are united by cartilage. So the difference is going to be the type of cartilage that holds them together. So we have the synchondroses. Now, let's unpack this word. What do you see? Chondr. So that refers to cartilage. Syn is together. So cartilage holds it together. So they're united by hyaline cartilage. There are two examples of this, and it's not super common. So one of them would one of them would be the epiphyseal plate in a child or adolescent's long bones. And then the other would be the first sternocostal joint. So that's the one between the first rib and the manubrium of the sternum. For various reasons, the other costal cartilage is seen as its own structure, not as something that holds a joint together. So if you read an anatomy textbook, what you'll see is a description of the costal cartilage and the joints it forms with the sternum on one side and the ribs on the other. And those two joints are slightly different. So in that case, we're not thinking about holding bones together. We're thinking about connecting the cartilage to the bone. I'm not sure exactly why this is seen as part of this joint. I'm really not. But a lot of this anatomy classifications come from things like embryology, where we study how the human body develops before birth. And that leads to some weird structures in weird places. And things like that can determine some classifications and names and stuff like that. So sometimes in anatomy, you just have to kind of just accept that not everything is intuitive. And then the other kind is going to be symphyses, and these are held together by fibrocartilage. One of these you might have already seen, the pubic symphysis, and then the other are going to be the intervertebral discs. So fibrocartilage, well, you tell me, there are two structures in the intervertebral disc. Which one is fibrocartilage? 3, 2, 1, pause. Yes, it is the annulus fibrosus. And the thing in the middle is the nucleus pulposus. So the little water balloon that gets squashed is the nucleus pulposus, and the tough ring of fibrocartilage around it is the annulus fibrosus. And then the pubic symphysis holds together the two pubic bones and kind of completes the pelvis. The pelvis has to be really strong in order to transfer all the weight of everything in the spine, in the vertebral column, to the femur. And sometimes you sit on your pelvis, and lots of other things happen. So the pubic symphysis gives it a little bit of flexibility, but also a lot of strength. Fibrocartilage is strong. That's it for the fibrous and cartilaginous joints, okay? The next video, we're going to move into synovial joints. We will start with what they all have in common, and then we'll look at one detailed example of the knee. So get ready for that.